Rolling contact bearings are usually installed with a press fit on one ring and a push fit on the other. Removing a bearing that has been installed with a push fit is relatively simple because it is a loose fit. Removing a bearing that has been installed on a shaft with a press fit is more difficult because it is a tight fit. The principles involved in removing a bearing that was installed with a press fit are the same, whether it is the outer ring or the inner ring that has the press fit. In this part, we'll look at two methods for removing the press fit inner ring of a bearing from a shaft. The first method is used when the shaft can be removed from the machine. This method uses a device called a hydraulic press. A hydraulic press is a machine that is frequently used to apply pressure to the parts of a piece of equipment that is being assembled or disassembled. A hydraulic press removes a bearing from a shaft by holding the bearing in place and pushing the shaft through the bearing. Let's watch a mechanic use a hydraulic press to remove a bearing from a shaft. To begin setting up the hydraulic press, the mechanic first adjusts the height of the bed. Then he places table plates on the bed. Next, he sets up the shaft in the bed. The mechanic lines up the shaft so that the table plates are supporting only the bearing's inner ring. This is important because if too much stress is placed on the outside ring, the bearing could be damaged. He also checks to ensure that the ram is positioned directly above the shaft. Next, the mechanic inserts the shaft protector between the shaft and the ram. After the shaft and the bearing have been lined up, the mechanic closes the pressure release valve on the hydraulic pump. Then he pumps the handle to begin applying force to the press. As the shaft starts to move through the bearing, he watches the bearing to make sure that it does not jump off its supports and to make sure that it is not cocked. If the bearing is cocked, it will jam on the shaft. As the shaft is forced straight down through the bearing, the mechanic holds onto the shaft with one hand to prevent it from dropping. The second method we will look at to remove a bearing uses a bearing puller. A bearing puller is a portable device. It is generally used to remove a bearing from a shaft when the shaft can't be removed from the machine. Before using the bearing puller to remove a bearing from a shaft, the mechanic applies penetrating oil between the shaft and the bearing. This oil makes it easier to remove the bearing. Then he sets up the bearing puller jaws behind the bearing so that they rest loosely against the shaft. Next, the mechanic hooks the side rods behind the jaws. Then he makes certain that both rods are aligned correctly on the strong back. In this example, the mechanic places the lead screw into an alignment hole in the shaft. Then he tightens the lead screw. He checks the position of the jaws to make sure that they will only push against the inner ring. A good way to check the jaw position is to tighten the puller and then turn the bearing's outer ring. If the outer race can move freely, then the jaws are positioned correctly. Next, the mechanic uses a wrench to tighten the lead screw and draw the bearing off the shaft. He is careful not to cock the bearing. If the bearing is cocked as it comes off the shaft, it will jam, and the puller will have to be readjusted. The mechanic continues pulling until the bearing is loose enough to be removed by hand. After the failed bearing has been removed from a shaft, the mechanic cleans the bearing with an approved solvent to remove grease and dirt. Then, after the bearing has dried, he inspects the rings and rolling elements. He turns the bearing slowly to determine whether there is any stiffness or binding when the rolling elements turn. He also checks for signs of failure such as spalling, burn marks, cracks, dents, and pits. Bearings that fail must be replaced. In this part, we'll watch a mechanic prepare to install a new rolling contact bearing. The mechanic begins by carefully removing and cleaning the damaged bearing. After a bearing has been removed from a shaft, it should be handled carefully. It should not be left where it will get dirtier, and it should not be rotated, banged around, or dropped. Handling the bearing carelessly will only make the task of determining why it failed more difficult. In order to properly inspect the bearing, the mechanic must first clean it. In this example, the mechanic cleans the bearing with an approved solvent to remove grease and dirt. Then, after the bearing has dried, he examines the bearing for signs of failure. He turns the bearing slowly to determine whether there is any stiffness or binding when the rolling elements turn. He also checks for signs of failure such as spalling, burn marks, cracks, dents, and pits. If the bearing has been damaged due to misalignment failure, lubrication failure, or thrust failure, the problems that caused the failure must be corrected. In this example, the bearing has simply worn out. After the cause of a bearing failure has been determined, the bearing should be discarded. Otherwise, it could be mistaken for a new bearing and reinstalled. The mechanic also inspects the shaft for signs of rust, nicks, or burrs in the metal. These imperfections should be removed before a new bearing is installed. The mechanic then selects the correct type of replacement bearing according to the manufacturer's specifications. He checks to make sure that the part number of the bearing specified by the manufacturer is the same as the part number on the replacement bearing. In this example, the mechanic's next step is to pack the new bearing with grease. Before installing the bearing, the mechanic measures the diameter of the shaft and the diameter of the inner ring with a micrometer to make sure that all the parts will fit together correctly. When all of these preparations have been completed, the replacement bearing can be installed. New bearings must be installed correctly in order to work properly. In this part, we'll look at two common methods of installing rolling contact bearings. One method uses a hydraulic press, and the other method uses a tubular drift. We'll start with the tubular drift method. A tubular drift resembles an ordinary length of pipe. The drift should be made of a soft metal to prevent damage to the bearing or the shaft. The inside diameter of the drift must be slightly greater than the inside diameter of the inner ring of the bearing that is being installed. If the drift and the inner ring were exactly the same size, the drift would jam on the shaft. The outside diameter of the drift must never be so large that it touches the rolling elements or the outer ring, because a drift that large could damage the bearing. When a tubular drift is used, the shaft stays stationary and the bearing is forced down the shaft. This method is generally used when the shaft can be removed from the machine and placed in a vise. If the shaft is left in the machine, its other bearings may become brunelled. The tubular drift method is both simple and efficient. Let's watch a mechanic install a bearing using a tubular drift. First, the mechanic secures the shaft in a vise. He then lubricates the part of the shaft that the bearing will slide over. This will make it easier for the bearing to slide onto the shaft. Next, the mechanic pushes the bearing onto the shaft by hand as far as it will go. He then places the drift over the shaft, checking to make sure that it does not touch the rolling elements or the outer ring. Then the mechanic uses a mallet to pound the drift against the bearing until it is in the correct position. When the inner ring of the bearing is flush against the shaft, the mechanic installs a lock washer and a lock nut. Another common method of installing a rolling contact bearing uses a hydraulic press. A hydraulic press is frequently used to apply pressure to the parts of a piece of equipment that is being assembled or disassembled. With a hydraulic press, the bearing stays stationary and the shaft is pushed through it. When a hydraulic press is used to install a bearing, the first step is to set up the press. First, the mechanic adjusts the height of the bed to fit the length of the shaft. He then places the table plates on the bed. Next, he positions the bearing on the table plates so that only the inner ring is supported. Next, the mechanic lubricates the shaft. The shaft is lubricated before it is placed in the bearing so that it will slide into the bearing more easily. Then he places the shaft in the bearing. The mechanic checks to make sure that the shaft is lined up directly under the ram. Then he places the shaft protector on the shaft and partially lowers the ram into position. Before operating the press, the mechanic checks the whole assembly again to be certain that everything is lined up properly. The mechanic then operates the press. He watches the shaft carefully to make sure that it moves smoothly into the bearing. If the shaft does not move smoothly into the bearing, the mechanic must stop the press because the bearing might be jammed. If this happens, the mechanic must correct the problem and then recheck the alignment of the bearing, the shaft, and the ram. He can then restart the press. After the bearing is on the shaft in the correct position, the mechanic stops the press and inspects the bearing. He checks to make sure that the entire surface of the inner ring is touching the shaft all the way around. The mechanic then removes the bearing and the shaft from the press.